Imagine trying to bake a cake where the oven speaks German, the mixer speaks Japanese, and the recipe is locked in a vault. That is essentially the state of modern automated science, a fragmented landscape of brilliant but isolated tools. The researchers identify a critical bottleneck. Scientific automation is currently built on custom bespoke systems. These setups are tightly coupled to specific labs, making it nearly impossible to seamlessly connect computational simulations with physical robotic instruments. To solve this, the paper introduces the Science Context Protocol, or SCP. This is a new connectivity framework designed to unify these separated worlds, creating a standardized bridge between dry computational labs and wet physical experiments. At its core, SCP uses a hub-and-spoke architecture. The hub acts as the brain, managing the scientific goals and history, while the servers act as the limbs, directly controlling microscopes, databases, and simulation codes. Let's look at how this connects in practice. The diagram illustrates how the hub sits in the center, coordinating the flow of information between human researchers and the diverse network of tools, ensuring everyone speaks the same language. You might wonder why they didn't just use the existing Model Context Protocol, or MCP. The authors argue that while MCP handles basic connections, science encounters complex, multi-step workflows that require persistent memory and specific drivers for physical hardware. Intelligence is built directly into this orchestration. The hub doesn't just route messages, it uses AI to analyze the user's intent, generating and ranking complex task graphs based on risk and cost before executing them. Ideally, this system scales well beyond a single experiment. They demonstrated this by building an intern discovery platform that successfully integrated over 1,600 tools across diverse fields like biology, physics, and chemistry. One of the most impressive capabilities is the ability to turn text into action. The system can parse a PDF of a standard operating procedure and automatically convert it into a structured protocol that robots can physically execute. They also demonstrated a complete closed loop in protein engineering. Here, AI agents designed proteins, robots physically synthesized and tested them, and the results were fed back to the AI to improve the next batch. This standardization creates a global web of scientific agents. By decoupling the research logic from specific hardware, SCP allows experiments to be reproduced anywhere, transforming isolated labs into modular discovery services. Ultimately, SCP proposes a foundational layer that could make autonomous science as interoperable as the Internet itself. To learn more about this protocol, visit emergentmind.com.